Tesla is quietly preparing a production plan that will push the real cost of a Tesla down to $12,595, and it will be one of the most disruptive manufacturing shifts in the entire history of automotives. But before we dive into it, make sure to subscribe to our channel for more Tesla World Breakdown videos. The $12,595 the question. Why this production plan is different from everything before Tesla is not going to build an affordable car by cutting corners or taking cheap interior shortcuts, as Elon Musk has been very clear about this internally and externally as well. He said there will be no weak points in the next generation, no fragile chassis, or any type of compromise on safety, just to reduce the prices. But instead, Tesla is this problem from the factory floor upward without any drawbacks in software or longevity of cars. The main reason why the $1295 figure is even being discussed again and again comes down to a radical shift in how cars are physically created. Traditional automakers are still relying on a process that is decades old, where thousands of stamped metal pieces, miles of welds, and long assembly lines are filled with workers who are busy correcting small errors. All these tiny steps add cost, time, energy use, and failure points in the production of cars, which affects the actual cost. Now, Tesla's new production plan will be able to remove most of these complexities entirely, as there will be the massive 50,000-ton Giga casting machine at the center, which is operating at Giga, Texas right now. They will change the entire philosophy of vehicle construction instead of being just incremental upgrades to existing equipment. Tesla is aiming to cast major structural sections as single, solid pieces rather than using thousands of small parts to assemble a car. The backbone of the car will be ready with 3 major pieces that are created as unified components, like the front frame, the rear frame, and the structural battery pack. This approach will change 2 things at the same time. Firstly, it will slash the cost aggressively, and secondly, it will also improve the strength and durability simultaneously. Now, you know how Tesla is going to achieve a price point that sounds impossible without turning the product into a disposable economy car. How Giga casting removes thousands of dollars per vehicle. To better understand how Tesla can potentially shave more than $7,000 off the original cost of a vehicle, first you have to look at the parts count. A conventional electric vehicle like Tesla can contain parts that are close to 30,000 individual components, and each one of them has to be sourced, transported, inspected, fitted, and secured properly to make sure the car is built for durability. The complexity of long processes adds up fast. The number of body-related parts will drop dramatically under Tesla's new production plan, where instead of tens of thousands of pieces, the core structure would rely only on a few hundred major components. This reduction alone will help save roughly $2,000 per car in materials, logistics, and supplier overhead, because fewer suppliers mean fewer delays in production, fewer contracts, and fewer chances for costs to inflate. Then there is welding, because all traditional EVs require thousands of weld points throughout their entire body to be assembled together, and each weld could be a potential weakness. So each one needs to be inspected separately, and each one of them consumes a lot of time and energy. That's where Tesla's GigaCast design will reduce price by cutting welds by more than 90%. And where other vehicles may use over 5,000 welds, this new Tesla platform will use only a few hundred. The result of this will also be seen in labor costs, which will fall sharply. Because of this Gigafactory, much of the labor-intensive work will disappear, unlike the older models of Tesla that still need dozens of workers along the assembly line for welding management, alignment checking, and structural inspection. This inspection will become automated, and robots will be handling the process with precision better than humans without any minor errors. This will further help Tesla save around $1,500 per vehicle. 440. Welding robots, quality control scanners, and rework stations consume an enormous amount of electricity. Energy use will also drop if these processes are eliminated or shortened. The saving of kilowatt hours on every single car may seem small individually, but the financial impact will become significant when applied across hundreds of thousands or millions of vehicles per year. When you put all that together, you will see that Tesla will actually be able to reduce the manufacturing cost of its next-generation vehicle realistically to a level that the industry has never seen before. That is how the idea of a sub-$17,000 car becomes credible and manageable. Furthermore, internal projections suggest it is possible, with continued optimization, that the cost could fall even further, which would open the door to something close to the $12,595 figure. Why cheaper doesn't mean weaker or less safe. Now, many of you might be thinking that low-cost vehicles must be flimsy or short-lived. But as we have discussed earlier, Elon Musk has confirmed that there will be no compromise on software or safety, and there will be no weak points in the next generation. The new platform from Tesla flips these assumptions upside down because the Giga frames are equipped with aerospace-grade aluminum that is heat-treated to give them an exceptional level of tensile strength. So instead of using dozens of welded joints that concentrate stress, the forces will be distributed evenly across a single cast structure. This change will cause fewer fatigue points, fewer cracks over time, and far less need for structural repairs as the vehicle ages. Tesla engineers strongly believe this chassis design can last decades with minimal degradation, under daily use. The structural battery pack will also play a major role here because instead of being a heavy module bolted into the car, it will become a part of the vehicle structure, which will increase torsional rigidity significantly while also improving handling, safety, and ride quality. Early data about this new platform suggests that this would be stiffer than the Model 3 while weighing substantially less than that. Weight reduction is considered critical because it improves vehicle efficiency throughout. Because a lighter car needs less energy to move, smaller battery packs can deliver a longer range. And Tesla can achieve impressive real-world range without inflating expenses with the help of lithium iron phosphate batteries, which are optimized for durability and cost. This is why Tesla is not expected to feel like a downgrade in the upcoming compact. It might actually be able to deliver better ride quality with fewer rattles and lower long-term maintenance costs as compared to several cars that cost twice as much today. If you're enjoying this deep dive, then do subscribe to our channel for more in-depth breakdowns of Tesla Factory's technology. The speed factor. How Tesla builds a car in seconds, not hours. Another strong pillar of Tesla's production plan is time, because Tesla is aiming to move towards seconds. While other automakers in the industry measure production speed in minutes per station and hours per vehicle. Inside Giga, Texas, multiple castings are produced simultaneously, where molten aluminum is injected into the Giga press at extreme pressure while filling the mold in under a second. And advanced cooling systems are also present there to solidify the cast within a few moments. Then these castings are transferred automatically to the assembly area. In Tesla's manufacturing process, which is called unboxed, major components are built in parallel and then brought together at the end, instead of making the vehicle crawl through a long linear assembly line. This dramatically reduces production time while eliminating bottlenecks. It can take only 5 seconds to build a complete chassis from raw metal, and this speed allows Tesla to scale output rapidly without the need to build thousands of new factories. It also prepares Tesla to respond faster than other competitors in the industry when demands spike, because others are still constrained by slow, labor-heavy assembly methods. Long wait times that frustrate buyers today will largely disappear because when this system becomes fully operational, Tesla is going to deliver vehicles almost immediately after ordering. Smart factories and zero downtime. The speed alone would not be enough to dominate the industry if quality suffers. Tesla addresses this issue with real-time factory intelligence, where every machine, robot, and sensor inside Giga Texas is connected through high-speed networks, which allow them to have instant communication. With this fast communication, Tesla's AI systems will be able to detect issues as they happen in production, instead of discovering defects hours later during inspection. Adjustments will be made in milliseconds that will reduce waste, prevent extensive reworks, and keep the line continuously moving. This is also the point where Tesla will be saving a lot of time and money, while other automakers can lose hours in diagnosing and fixing production issues again and again. This advanced system is also designed to correct itself on the fly due to AI integration in it. Less downtime will eventually cause higher output and lower cost per vehicle. When this car actually reaches drivers, timing matters as much as cost, and Tesla's next-generation vehicle is positioned to arrive as market conditions are shifting dramatically because affordable Chinese EVs are now facing heavy tariffs in the US. Tesla's production plan will allow it to fill the gap in the market, while many American buyers are being priced out of the market entirely. The ramp-up will not require a decade-long transition to be in action, as factories are already being upgraded and tooling is in place. Volume will be able to scale at a pace that only a few competitors can match once the switch is flipped. Internal timelines are pointing towards US deliveries ready to begin in early 2026, and pre-orders will be opened well before that. Buyers may not have to wait several months after placing orders because production will be quite fast. This immediacy will serve as a major competitive advantage for Tesla. The story doesn't end with the purchase price, while Tesla's real long-term advantage lies in software, autonomy, and network effects. The upcoming vehicle will be designed from day one to support Tesla's latest full self-driving architecture. With improved AI chips and more powerful onboard computing, this platform will be built to handle advanced autonomy once regulations allow. Tesla's data already shows that vehicles using its newest systems experience far fewer accidents per mile than human-driven cars. Why this production plan threatens the entire auto industry? Tesla's $12,595 production target isn't just about one model, but it's actually a complete blueprint for all upcoming generations. Once the system is proven, it can be replicated globally, and other factories can adopt the same processes for pushing costs down even further. Legacy automakers will face a painful dilemma when they won't be able to easily abandon their existing infrastructure, and competing with Tesla's cost structure will become increasingly difficult as well. Because retooling factories, renegotiating supplier contracts, and retraining workers takes time and money they may not have. This is why Tesla's manufacturing strategy matters more than any single vehicle announcement, as it will serve as the foundation for long-term dominance in both affordability and scale. Conclusion. With Giga casting, ultra-fast assembly, and AI-driven factories, Tesla's new production plan is not only about making a car cheaper, but it is actually about reinventing how cars are built. With all these happening in real time, the path toward a $25,995 Tesla is slowly becoming real. If you enjoyed watching this video, then don't forget to subscribe to our channel for more deep dives into future revolutionary innovations.